In today's lesson, we're going to revise what is matter, properties of matter, how can we change matter from one state to another state. This revision is meant for the primary 4s and the primary 5s. We are going to be using the primary 4 essay 2 practice paper and the primary 5 essay 2 practice paper. Now, if you do not have the practice paper because you're a primary 5 student, looking at the primary 4 questions, simply pause the question, try it on your own on a piece of paper, and then let it play again to look at the explanation. Likewise, if you're a primary 4 student looking at the primary 5 practice paper on the same topic, you will not have the question. All you need to do is to pause the video, try it on a piece of paper first, try answering it, and before you play, and then listen to the explanation. Hi, I'm Mr. Long, and I will be revising with you today. Now, as part of today's revision, we will not go into the questions first. Instead, we do some simple demonstrations to understand properties of matter. Now, this first diagram here, alright, we start off with a diagram. This first diagram should not be unfamiliar to the primary 4s. Okay, for this part here, you know that matter exists in 3 states: solids, liquid, and gas. Now, in the primary school syllabus, you will encounter this matter known as water, and water in the liquid state is simply water. And of course, water in the solid state is ice. Water in a gaseous state will be simply water vapor. Will you be exposed to other materials with different melting points, freezing point, boiling points? Of course, but you will not be needed to know their specific temperatures, which I've just mentioned, at melting point, freezing point, boiling point. Instead, you just need to know the general idea of, basically, number 1, matter exists in 3 states, no matter what kinds of matter they are, and you are able to change them from one state to another by either gaining or losing heat. So, primary 4 will still need to know this, right? Solid, liquid, gas. An example of solid is ice, and when ice melts, you get water. When water evaporates, you get water vapor. So how do you change from this state to this state? There must be a gain in heat. From here to here, it's also a gain in heat, right? From water to become a gas. And for the gas to return to this liquid state, it has to lose heat to the surroundings. And for water in the liquid state to become ice, it has to lose heat to the surroundings. Okay, so far? Now, for the primary 5s, you need to know the specific terms of the processes. In this case here, this will be known as melting. And for water, it occurs at 0 degrees Celsius. The primary 4s, you need not know the parts in pink. These are meant for the primary 5s. By the primary 4s, you'll be learning this next year. So right now, just take it as an enrichment. For liquid to become a gas, there can be 2 processes. Either it's boiling, and for water, you'll be at 100 degrees Celsius. But it can also become a gas by gaining heat, but not so much heat. You could be gaining heat at maybe 25 degrees Celsius, 30 degrees Celsius, 10 degrees Celsius, 45 degrees Celsius, anything between 0 to 100, and that is process called evaporation. Right, that can be from 0 to 100 degrees Celsius, anything in between. Not at 0, not at 100, but in between. Now, from gas to become a liquid, it must lose heat. This process is known as condensation. And there's usually a cooler surface that this water vapor will lose heat to and condense to become water droplets. And here, this process is known as freezing, when liquid turn into solid. For water, this will occur at 0 degrees Celsius. So notice that the melting point of water is at 0 degrees, right? Melting point of ice is at 0 degrees Celsius. The freezing point of water is also at 0 degrees Celsius. And the freezing and the melting points are at the same temperature for the same matter, alright, at 0 degrees Celsius. Now, this is a quick revision into states of matter. Now I go into the properties, and the properties is what we'll be trying to demonstrate today. Now, what properties do a solid have? A solid definitely has mass. How do we know it has mass? Well, we can use a weighing scale such as this. Alright? Yes, very cute, right? Hello Kitty. So let's turn it on. So I hope you can see the digital scale here. Very soon you will see 0, so I'm pressing on the scale. So what I have in this hand here is just some blue tag. Alright, and blue tag is a solid. So let me just remove this part. So does it have mass? We will know if we were to place it on the weighing scale. So let me leave it up so you can see clearly. Okay, let me just tear it first so it's set to 0. Let me try again. Right. Okay, now you have to place this blue tag onto the surface here. Alright, it will register a number here. And you should see 14. Right, 14 grams. That's the mass of the blue tag. So it is a matter, it is a solid state, it has mass. Same for liquid as well and for gas. Now, what if I were to make this piece of solid smaller? Will that reduce the mass, or the mass remains the same? Let's try. Let me just make it into a smaller piece now. 2 smaller pieces. Okay. Oops, okay, this part. Let's see. I'll place one piece here, another piece here. Notice that the mass, alright, should be the same for these two. So you can see, I'm not sure you can see it. Okay, if I remove this, let's try again. When they are in one piece, you will see the mass here is 14. I hope you can see this is 14. Alright, let me just leave it up. 14. So when I leave it up, somehow the scale will change in the figure because I interfere with it. So I hope you can just see it clearly enough. It's at 14. So it's now it's 13, but when it's resting on the table it's 14. Right, I hope you can just take my word for it for now. It's at 14 grams. When I will separate these two and make them into 2 smaller pieces, that mass remains the same at 14. Alright, at 14 grams. If I separate them into even smaller pieces, the mass still remains the same at 14 grams. Right, let me try one more time for you to see this. Okay. Alright, I guess my weighing balance is a bit too sensitive. Whenever I move it, the figures changes. So at least you can see whenever this thing changes, right, in size, the mass will also change. The mass will remain the same. Alright, mass will not change, even the size is reduced. Now, next demonstration will be regarding to another property of matter. So how about the shape? Now, of course, this shape is a definite shape. When I apply a force on a solid, of course I can change the shape. But if I don't apply a force, the shape is fixed. So a solid has a fixed shape. How about liquids? Liquids has mass too, right? Liquids also has mass. But the shapes of liquids can change. For example, there's some liquid in this test tube, alright? And the shape would be, how would I describe it? Maybe like this, inside the test tube. But can I change the shape? If I tilt it, if it's a liquid form, the shape changes. Now it is like this. And if I pour this liquid into a different container, now the shape changes again. Now if you look from the side, the shape now becomes actually like this. Look from the top, the shape actually is just this, right? So this is how shapes how liquids do not have a definite shape. Liquid has a definite mass, but it has no fixed shape. Alright, gases also has mass. Gases also has no fixed shape. how can we see that gases actually occupy space too? Because if it has mass, of course, it also has volume, right? Has mass. One more property is they will all occupy space. Solid will occupy space. This solid occupy the space here. Alright? The liquid occupy the space inside this container. Liquid also occupy space. How about for gas? We can't see air. Alright, air is made out of many gases. Air also occupy space. Let's see this example in action. So what I have here is a simple setup. Let me then explain the setup to you. This is just a tube. I'll be blowing through this end later, right, to blow in some air out from this side. Now this here is a beaker filled with water. I'll try to show you. Oops. Alright, let me show you this. So I'll remove all the air bubbles from it first. Alright. Now it's completely filled with water. Only water is inside all the way to the top. No air bubbles at all. Hope you can see that. Right, just water. And this is what I call a beehive. This is a setup with, you notice there's a gap here, which I will insert this in later, so I can blow some air in. Air will come up from this hole into this beaker. I will place this beaker gently over the beehive. Okay, now currently the space inside this beaker is occupied by something. What is occupying the space inside the beaker? You're right, it is water, liquid water. So what if I were to force some air in? Will air be able to occupy the space inside? It can only occupy the space inside if the air can force out the water that's already there. It's like if you're sitting on a chair and a friend wants to sit on the chair, your friend can either ask you gently, or your friend could be unkind and push you off the chair, right, to force you off before she can sit down. Let's see if this really happens. As you can see, as I blow air in, alright, air is forcing the water out from the sides, and air is taking out the space inside. And air can only take out the space inside if it can push the water out from this container, this beaker. Let me try to see if I can push out even more. As I do so, of course, the water level outside in this big container will increase, because the water inside this beaker comes out and fill up the water in the big container. Let's see from the side, if you can see the air bubbles now inside. Can you see now there's air inside? Okay. Alright. So this simple experiment shows that air also occupies space. In the next video, we will go in to look at the questions. Right now that we have revised through these basic properties of matter, so let's do a recap before we move on to the next video. So we have looked at this already, that matter exists in three states: solid, liquid, gas. Alright, and when matter gains heat, it can change state. When matter loses heat, it can also change in this state. Alright, solid has mass, has a fixed shape and occupies space. Liquid has mass, has no fixed shape, occupies space. Gas has mass, has no fixed shape, and it also occupies space. And notice, no two matter can occupy the same space at the same time. For one matter to occupy the space that another matter was occupying before, it has to first move the other matter out. Alright, thank you for listening. Now get ready with a piece of paper and your pen and your practice paper, right, if you're a Primary 4, Primary 5 student, and let's get ready to understand the questions. See you later.